Hello, my name is Wilson Perlaza. I am a student Technical English 2. My topic is silent switcher regulator high efficiency with ultra low EMI. Silent switcher. A silent switcher regulator is typically the first activated component on the input power bus line and therefore has a significant impact on the EMI performance of the complement circuit. There are two types of EMI emissions, conducted and radiated. Conducted emissions ride on the wire and trace that connect up to a product. Radiated emissions testing cannot be formally performed until the design is essentially complement. This webcast will highlight a new technology that significantly reduce EMI emissions from switching regulator. What's behind silent switcher? We reduce the magnitude of the harmonic by eliminating parasitic, no more long bond wires. We reduce the energy in the harmonic by splitting the hub lobes into two lower powered lobes. We prevent the EMI from propagating by having the fields from the two loops cancel each other out. Internal switch driver minimized switching power loss, producing fast. Clean switching edge. To input caps a rush to cancel magnetic fields. For example, the circuit. Other example, demo board and location. Applications in electronics. Silent switcher break the trade-off between EMI and efficiency by not needing to slow down the switch X. Applications: automotive always on systems, automotive call current, automotive test equipment, distributed supply regulations, industrial test and measurements, medical equipment, signal processions, applications. Imagine an RF system. Fixture. Variable for increased output current, multi-output configurations, ultra-low quiescent current and output ripple. In burst mode operations for operating modes, burst mode, pulse skip mode, forced continuous mode and external synchronizations, mode lower out replete. Pros and cons. Pros: high efficiency conversations and greater than 2 MHz switching frequency with minimum impact on conversions efficiency. Internal bypass capacitor reduce EMI radiations and provide for a more compact solution for prime PCB. Layout sensitivity is essentially eliminated with silent switcher 2 technology. Cons: modern input filter components in source mount technology have better performance than through-hole parts. However, this improvement is outpaced by the increase in operating switching frequencies of switching regulator, higher efficiency, low minimum on and off times result in higher harmonic content due to the faster switch transitions. Conclusions. In conclusion, silent switcher capabilities and benefits will make it easier for you to switch mode power supply, designed to pass the various noisy immunity standards such as CISPR 32 and CASPR 25. Below a video to complement the topic.
High-speed analog-to-digital converters have evolved into the gigasamples per second realm with a corresponding increase in serviceable bandwidth. These performance improvements come with a number of challenges, one of which is more complex power supply requirements. For example, the 89625, a 2.6, 2.5, and 2.0 GSPS sampling ADC requires 7 independent power rails divided into various voltage levels. The complete ADC power system must be efficient, fit on an already crowded PCB, and produce output noise that matches the supply sensitivity of the load. Balancing these requirements often at odds with each other is an overriding parametric optimization problem for the system designer. Conventionally, the problem is solved by combining switching regulators, noisy but efficient, with low dropout or LDO regulators to minimize the switching noise in the power supply path. Hence, the traditional baseline power supply system for 89625 consists of 2 switching regulators, an ADP2386 20V 6A step-down converter with an LC filter that act as pre-regulators to 3.6 and 2.1 intermediate voltages. These intermediate voltages are further stepped down by LDOs on each regulated ADC input rail. The LDOs provide the regulated voltages to the ADC and are effective in reducing the output ripple from the switching regulators. The traditional baseline system successfully produces well-regulated low-noise outputs, but at the cost of complexity. An alternative and simple power solution consists of 2 LTM8065, a power bilinear 40 volts input 2.5 amp continuous step-down silent switcher micromodule regulator, and a single ADP7118, a 20 volts 200 milliamp low-noise CMOS LDO. Micromodules enable a compact PCB solution because key regulator components are already integrated in the package. Silent switcher technology, on the other hand, virtually eliminates unpredictable and difficult to filter high-frequency noise, translating to a power source well suited to the ADC. In this solution, the LTM8065 directly powered the 1.3 and 2.5 volts rails, while the 3.3 volt rail is powered directly by ADP7118, coming from a 12 volt input supply. The 3.3 volt rail current is less than 1 milliamp, so power dissipation across the LDO is negligible. The LTM8065 module silent switcher regulator can power the 89625 without the use of additional LDOs, greatly simplifying the overall solution. It also offers significant improvements over traditional discrete solutions, such as reduction in component count and power supply board real estate, much higher efficiency and better thermals without even compromising the dynamic performance of the ADC. For more information, please visit analog.com.